Uh, so let's look at alkanes. Now, alkanes are hydrocarbons. We saw that hydrocarbons are compounds made up of carbon and hydrogen only. And we saw that there are three classes of hydrocarbons: alkanes, alkenes, and alkynes. So let's look at alkanes as a class of hydrocarbon. Now, alkanes can be represented by the general formula CnH2n plus 2. All alkanes fit that general formula, and usually compounds which can be represented by the same general formula are said to belong to the same homologous series. So because all alkanes can be represented by this general formula, we say that they belong to the same homologous series. Now we'll start by naming the first 10 alkanes and giving the formula basing on this general formula CnH2n plus 2. So let's see. You expected to be able to name the first 10 alkanes. So basing on the general formula CnH2n plus 2, the first member N should be 1. Now if N is 1, then it means there's only one carbon atom. Then 2 times 1 is 2 plus 2, that gives 4. So the first member, known as methane, has molecular formula of CH4. Then there's what we call the structural formula. Structural formula can either be open or condensed. The open structural formula will be C, that is carbon, onto which 4 hydrogens are bonded. Remember, carbon belongs to group 4 of the periodic table, so it forms 4 covalent bonds. So you can clearly see on this carbon there are 4 covalent bonds. The condensed formula will be CH4, that is condensed. So the open structure is where you show exactly where each bond is. The next member, the value of N will be 2. So that gives us C2. Then when you take 2 times 2 is 4 plus 2, that is 6. So that is C2H6. That compound is known as ethane. The open structure, the 2 carbon atoms bond to each other to form a chain. Now since there is a bond here, this carbon already has one bond, so it will bond to 3 other hydrogens. Then also this carbon will bond to 3 other hydrogens, each carbon having a total of 4 covalent bonds. The condensed formula, you just show the first carbon has 3 hydrogen, so that is CH3. The next carbon also has 3 hydrogen, that is CH3. Let's look at the third member. N is 3, so that is 3. Then 2 times 3 is 6 plus 1, that is 8, so H8. That compound is known as propane. The open structural formula, the 3 carbon join to each other using a single covalent bond. So 1, 2, 3, they are joined by a single bond. The first carbon, because it has already a bond here, it will bond to 3 hydrogen. The next carbon is bonded to this carbon and this carbon, so it will bond to only 2 hydrogen. The last carbon will bond to 3 hydrogen. You notice that each carbon has 4 covalent bonds. The condensed formula, the first carbon has 3 hydrogens, so that is CH3. The next one has 2, that is CH2, and then CH3. That is the third member. The fourth member, called butane, the value of N is 4, so that will be C4. Then hydrogen, 4 times 2 is 8 plus 2, that is 10, so H10. Now the 4 carbon atoms are joined to each other through a single covalent bond. So you can see the 4 carbon atoms, 1, 2, 3, 4, each joined by only one covalent bond. Now you notice that the carbon at the end, sometimes we refer to them as terminal carbon, will have 3 hydrogen. Then any carbon that is not at the end will have 2 hydrogens. So you can see this has 2, this has 2, then this is at the other end, it has 3 hydrogen. The condensed formula will be CH3, CH2, CH2, then CH3. The 5th member, known as pentane, N is 5, so that is C5, H 5 times 2, 10 plus 2, that is 12. So you just show the 5 carbon joined through one covalent bond. So 1, 2, 3, 4, 5. Those are 5 carbon atoms. We've seen that the carbon at the end of the chain, the terminal carbon, will have 3 hydrogen. Any carbon in between the chain will have 2, 2, 2, and then 3 hydrogen. This can be condensed as CH3, CH2, 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 and CH3. So terminal carbon, 3 hydrogen. Any carbon in between will have 2 hydrogen. The 6th member is known as hexane. So N is 6, so 6 carbon atoms. Then 6 times 2 is 12 plus 1, that is 14. So put the 6 carbon atoms in the chain. So that is 1, 2, 3, 4, 5, 6. Remember, each is joined by only one covalent bond to form that chain. The terminal carbon, you put 3 hydrogen. Any carbon in between 2 hydrogen, 2 hydrogen, 2 hydrogen, 2 hydrogen. Then here 3 hydrogen, which can be condensed as CH3, CH2, 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 then at the end CH3. That is alkane number 6. Then alkane number 7 is known as heptane. So N is 7, so that means C7, then H16, because 7 times 2 is 14 plus 2, that is 16. So again, you just put the 7 carbon atoms in the chain. 1, 2, 3, 4, 5, 6, 7. Terminal carbon, put 3 hydrogen. All other carbons in between 2 hydrogen. Terminal carbon, 3 hydrogen. So you condense as CH3, CH2, 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 then CH3. That is number 7. Then alkane number 8 is known as octane. So N is 8. So that is C8. Then 8 times 2, 16 plus 2, 18. So 18 hydrogen. Just follow the same rule. Put all the 8 carbons in the chain, all of them joined by single bond. So 1, 2, 3, 4, 5, 6, 7, 8. Terminal carbon, 3 hydrogen. All the other hydrogen carbon, 2 hydrogen, except again terminal carbon here with 3 hydrogen. To condense CH3, then CH2, 6 of them, the last one CH3. That is octane. Number 10 is non-N. So N is 9. That is C9, H20, because 9 times 9 is 18 plus 2, that is 20. Then again, just 9 carbon atoms in the chain. That is 1, 2, 3, 4, 5, 6, 7, 8, 9. Then fit in the hydrogens. So terminal carbon, 3 hydrogen. The rest have 2, then 3 here. Condensed, the same thing. CH2, CH3, then CH2, that is 7 times, then at the end CH3. Then the last member, number 10, of course there are more than 10, but in your syllabus you need to know only the first 10. That is decane. So N is 10, so C10. Then 10 times 10 is 20 plus 2, that is 22. Again, just follow the same rule. 10 carbon atoms, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3 hydrogen on the first carbon, 2 on the rest until the last one here, which will have 3. So condensed, you have CH3, then CH2 8 times, then CH3 at the end. Those are the first 10 alkenes. So remember, we said they fit the general formula CN H2N plus 2, and such compounds that can be represented by the same general formula, we say that they belong to the same homologous series. Another interesting thing you notice about alkenes, their names will always end with A and E. So methane, ethane, propane, butane, pentane, hexane, heptane, octane, and nonane. So that is in as far as naming of alkenes is concerned.